Before the Burj Khalifa ever touched the sky, there was nothing here but desert. Flat sand, heat rising off the ground, and a bold idea that many believed was impossible. This is the story of how humanity built a structure so tall it almost seems to defy the laws of physics. The challenge was simple to describe, but nearly impossible to execute: build the tallest structure humanity has ever made. This elegant, nature-inspired design made the impossible possible, but a brilliant design was only the beginning. The real, unseen challenge was hidden beneath the sand. For a building this tall, the ground itself becomes part of the structure. Engineers couldn't just build on top of the desert floor. Et very single pour, night after night, perfect. There was no room for error. Once the foundation was secure, the structure began its slow, steady climb into the sky. But unlike most American skyscrapers, which rely on a steel skeleton, the Burj Khalifa was built primarily from high-performance, reinforced concrete. This material was specially engineered to handle the extreme pressure at the base of the tower. Floor by floor, the tower climbed higher. The construction site was a symphony of precision and repetition. Each level followed a strict rhythm. The concrete was poured. It was left to cure. It was inspected with incredible scrutiny. And then the cycle repeated for the next floor. The temperatures at the top were significantly cooler than on the ground, and the sway became noticeable. At extreme heights, construction workers could actually feel the building moving gently beneath their feet. A constant, subtle dance with the wind. The tower was designed to sway up to 7 feet at its peak to absorb wind forces without breaking. And yet, through all the challenges, it kept rising. Because this wasn't just a building anymore. It was a test of human limits, a statement of ambition written in concrete and glass against the sky. The final piece of the puzzle was the spire. This gleaming steel pinnacle, stretching over 700 feet, is what truly secures the Burj Khalifa's place in history. But hoisting it to the top was one of the most audacious phases of the entire project. It was le nerve-wracking process, pushing Fanapisa Tower into its record-breaking position. Finally, in 2010, after more than 6 years of construction and 22 million man-hours, the Burj Khalifa was complete. It stands at a staggering 2,717 feet, a testament to what happens when ambition, innovation, and relentless determination come together. From an empty patch of desert to the tallest man-made structure on Earth, the Burj Khalifa is more than just a skyscraper. It is a symbol that the line between what is possible and what is impossible is only drawn by the limits of our imagination. It reminds us that sometimes the most audacious ideas are the ones that change the world. Thank you so much for watching. If you enjoyed this journey into mega engineering, don't forget to like this video and subscribe for more stories about the incredible things humanity can build. We'll see you in the next one.
When the Burj Khalifa finally pierced the clouds, it had already redrawn Dubai's skyline forever. But the hardest part, the real test of engineering, was still to come. The tower cranes that built the lower floors simply can't operate safely at those extreme elevations. So the engineers had to get creative. They designed custom-built climbing cranes machines capable of lifting themselves upward as the building grew taller. These cranes were anchored directly to the concrete structure, essentially riding the very tower they were helping to create, moving higher and higher section by section. It was a slow, painstaking process, but it was the only way to reach the top. Of course, it wasn't just about getting materials up there. The wind is a relentless, powerful force that can create dangerous vibrations in a tall structure. To combat this, engineers conducted constant, exhaustive wind tunnel testing on models of the tower. They used the data to adjust the building's shape as it rose. This is why the Burj Khalifa doesn't just go straight up. It's designed as a series of steps, with each tier stepping back from the one below it. This isn't just a style choice. It's a brilliant engineering solution. These setbacks disrupt the airflow, breaking up the powerful wind vortices that could otherwise cause the tower to sway dangerously. The shape is the solution. While the structure was rising on the outside, a different kind of challenge was unfolding on the inside. Imagine installing the building's organs, miles and miles of piping, wiring, and ductwork that had to run from the ground floor to the very top. Take water, for instance. It had to be pumped upward farther than in any building in history. To make this happen, engineers designed a special pressure zone system. This means the water is pumped up in stages to different holding tanks throughout the building. This ensures that when you turn on a faucet on the 100th floor, the water pressure is just as reliable as it is on the ground floor. It's an invisible marvel of modern plumbing. In a building this size, that adds up to millions of gallons of water each year. In the middle of the desert, nothing is wasted. The grand finale of the construction was the spire. The final gleaming steel pinnacle wasn't built on top of the building in the open air. Instead, it was assembled piece by piece inside the tower's core, hidden from view. Then, using a powerful hydraulic system, it was slowly and carefully lifted upward through the center of the building. For weeks, the world watched, knowing the tower was getting taller, but no one could see the final piece. The amount of concrete used was enough to build a highway from Dubai to Abu Dhabi. Thousands of workers from over 100 different countries came together to make it happen. Engineers, welders, crane operators, designers, every single person played a crucial role in creating something far larger than themselves. The Burj Khalifa proves that modern engineering isn't just about brute force or building bigger for the sake of it. It's about precision. It's about planning. And most importantly, it's about understanding the forces of nature well enough to work with them, not against them. From the outside, the tower looks calm, still, and permanent. But inside, it's constantly alive. It's a dynamic structure, always adjusting to the wind, the temperature, and the subtle movements of the earth. A network of sensors constantly monitors stress, sway, and its overall structural health. The building isn't frozen in time. It's responding to its environment in real time, every single second, and that really is what makes it so remarkable. What began as an ambitious idea in the middle of the desert became a global icon. It's a symbol not just of wealth or ambition, but of what happens when human beings decide that limits are not barriers, but challenges to be overcome. This is how the world's greatest structures are built. Not in a single moment of genius, and not with one single breakthrough technology. They are the result of years of meticulous planning, millions of individual decisions, and thousands of people pushing forward together, one floor at a time, until they touch the sky. Thanks for watching. If you found this journey into engineering fascinating, don't forget to like and subscribe for more stories behind the world's most incredible creations.